Okay, so rational numbers are fractions, so that's definitely rational. Repeating decimals are rational. Also decimals that stop, like if we had something like 2.5 or something, that would be also rational. Irrational, that's square root of a non-perfect square. Cube root of a non-perfect cube would also be irrational. However, this one is equal to -2. You know, you can take the negative an odd root of a negative number and still get an answer. So that's nice and rational. So I would circle that answer. 2 to the 1/2 is the same thing as the square root of 2, and that is definitely in the irrational camp there. The decimal keeps on going. It doesn't repeat at all. So in this kind, there are 2 digits repeating. So I think we take the original number and kind of do the x equals 3.5. I'm just going to write a bunch of 6 2's. And then you would multiply by 100 because 2 digits are repeating. And so that would be 356.262626, etc. That eventually repeats. And then you're going to subtract, you get 99x equals, let's see, the second digit is a 6 for both of them, the third digit is 2. Those all cancel. 2 minus 5, so that would be 7. I carry that 1, so that would be 5 minus 3 is 2. And then 5 and 3, 5. And then you would divide by 99. Divide by 99. You basically have your answer, but it's decimal and a fraction. We don't want that, so we're going to multiply by 10 over 10 to get 3,527 over 990. So on these, I like to put the word kind of up above. So this one would be greater than, so x greater than -3, so arrow to the right. X less than or equal to 2, so close circle at 2 and arrow to the left. I go all the way to the end. And means we're looking for the overlap. So I only want the overlap. I don't want arrows on the end of this final graph. So my final graph is on the number line itself. Notice that's unattached. So I'm not grading that. Whatever is attached to the number line, I'll grade. You have open circle there, closed circle there, and everything in between would be graphed. Now you'd say the answer, probably in terms of interval notation, it seems like more sense here. So -3, 2, bracket, parentheses. Or you could say -3 less than x less than or equal to 2. Either answer would be okay. So you want to simplify your answer. Don't leave your answer in that form. It can be written in a simpler way. Very similar problem here. So we're going to look at x greater than -3, x less than or equal to 2. Same kind of stuff up above. Or means anything solution. So not just the overlap, but anything over here. Anything over here is also a solution. So it ends up being the whole number line. The graph is the number line, and the answer is all reals. Or you could say from -infinity to infinity. So you would say it starts at -2, it goes on to infinity, always parentheses with infinity, and parentheses because it's non-inclusive, does not have an equal sign. This looks like from 0 to 8, bracket, parentheses. Okay, so 250. So off to the side, you want to do kind of a prime factorization of 250 or use your factor command on your calculator. So it looks like I have 3 5s and a 2 there. So that's helpful that I have 3 of something. I'm looking for 3 of anything. I have 3 5s. So the 5 is going to come out, but the 2 is left over inside of there in the cube root of 2 plus, let's see what 16 has. So 16, if you do that, prime factorization, 2 and 8, 2 and 4, 2 and 2. So I have a group of 3 2's and a group of 1 2 left over. So 1 2 is going to come out, but I still have a cube root of 2 inside. That's handy because now I have 5 cube roots of 2 plus 2 cube roots of 2. You have a total of 7 cube roots of 2. Here, there's lots of things you could do here. You could deal with the negative exponent first. I might do that. So we could write this as one big fraction, the reciprocal of, so 1 over 27a to the third to the power of 2/3 positive now. So the negative exponent just really makes everything flip it reciprocal. Okay, so now everything's being put to the 2/3 power. 1 to the 2/3 power is just 1, so the numerator is just 1. In the denominator, you're going to have 27 to the 2/3 times a to the, remember your power, you're going to multiply, so 3 times 2/3 is actually 6/3 or 2. So that simplifies nicely. There's a lot of different ways you could approach 27 to 2/3. You could think of that as, I'm just going to do it this way, just you can do it different ways. You can write 27 differently, so that's to the 2/3. You could write that as 3 to the third if you look at its prime factorization. So if you're kind of stuck, that's always a good way to go. Oh, well, that's not too bad. So that would just be 3 times 2/3 is 6/3 or 2. So it's 1 over 3 squared or 1/9 a squared, 1 over 9a squared. Here, there's a lot of ways to go as well. I might just distribute that -1 to all of the terms inside. That's okay because there's no adding there. So this would make this 4 to the -1, x to the +2, 3 to the -1, y to the +3. And now the negative exponents there will also be reciprocal of that one. So that would be, I guess you'd have 3 in the numerator now and 4 in the denominator. And you could have done that differently. You could have flipped the whole fraction to start with and then deal with the negative exponents on the variables. That would have been okay as well. Again, I'm just going to deal with the negative exponent first. I kind of like dealing with the negative exponents first. So 9/4 to the +1/2. And then we're going to, everything's being put to the 1/2 power. So that's 9 to the 1/2 power over 4 to the 1/2 power. I really hope you know what 1/2 power is in disguise. If you don't, we can just change the form square root of, so this is the second root of 9 to the first. This is the second root of 4 to the first. In other words, 1/2 power is really just square root in disguise. So square root of 9 is 3, square root of 4 is 2, and you got your answer. So expand means to multiply it out. We're going to kind of FOIL this. So first times first, that would be x to the first power. You add the exponents. 1/2 plus 1/2 is 1. If you do last times last, because different squares, that's really all to do, and this would be y. This one, you really have to FOIL this, right? Because that's what it's a binomial times a binomial. And unlike this one, where we only had to do first and last, inside outside will cancel out, we're going to have to full FOIL it here. So this would be 4x squared minus 2x minus 2x. So I'm going to say minus 4x. Then plus 1 when you add that one in. Don't forget to distribute that to all the terms. I sometimes change this to plus, minus, minus, plus. Then just add like terms. 3x squared plus 4x squared is 7x squared. Negative 5x minus 3x is minus 8x. 8 plus 6 is plus 14. Factor the expression completely. So first thing you want to do is take out a GCF. That makes this problem a lot easier. And now the factoring actually isn't that bad. Hopefully you see it. It's difference of squares. 9a squared is a perfect square, so 3a and 3a. 25 is a perfect square, so 5 and 5. The square root of both those. One of them is plus, one of them is minus. The difference of squares. Pull out a 3 here if you see it. So x squared minus 10x plus 9. And then keep going. Maybe it factors some more. I'm guessing it does. 9 and 1 maybe. And maybe both negative, it looks like. You got it. Okay, so we have the x to the 5th minus 2x to the 4th plus, I'm going to put the second two terms, not changing the signs, I'm just putting them in parentheses. So pull out GCF, well, that's x to the 4th times x minus 2 minus, I'm pulling a negative, x times x minus 2. Wow, so I get x to the fourth minus x times x minus 2. Now that can be simplified quite a bit. So I don't know if you see it, but there's definitely an x in that first parentheses. So x times x cubed minus 1 times x minus 2. And I hope you see this. Do you see this goes further? So that's difference of cubes. So this will simplify even further. So that would be x minus 1 times x squared plus 1 times x plus 1 times x minus 1. So that was difference of cubes right there. Hopefully you have that formula memorized, the a cubed minus b cubed, because 1 is like being cubed there. It's like 1 cubed is the same as 1, so that's a perfect cube. Here, wow, this one looks tough. So I'm going to use the AC method. When it's kind of tough, I'll use the AC method. So A is 3, C is negative 4, so negative 12. So I'm going to factor negative 12 all the different ways I can. 1 and 12, 2 and 6, 3 and 4. Do any of those add up to negative 11? Well, maybe. So if we make that one, I think that could work. So I'm going to split up that middle term. It's going to be 3x squared minus 12x plus x minus 4y squared. I'm sorry, that's plus xy. That's xy also, sorry. I didn't see the xy there. Okay, so we split up that middle term using those factors we found that added up to negative 11. So now we're going to regroup them, the first two, next two. Pull out the GCF. It looks like it's going to be 3x times x minus 4y plus y times x minus 4y. And so we get the result of, it does match there. So one of them is x minus 4y, and one of them is 3x plus y. This one fits the form of difference of cubes, so it's just a matter of seeing that's 3 to the third, that's 2 to the third, that's x to the third minus in between. So your a is 3x, your b is 2, and you're plugging into the formula. So it'd be 3x minus 2 times 3x squared, which is 3x times 3x, which is 9x squared, plus 2 times 3x, which is 6x, plus 2 squared, which is 4. This one, wow, it's got a lot to it. I do see that 3 is a GCF. Looks like x squared is part of the GCF, and y squared is also part of the GCF. Let's take those out and see what this looks like. This would be x to the third, y to the third, minus 5y plus 8x squared. That's it. I think you're done. So that is considered factoring because I took the same term out of every term. If you can only take it out of 2 terms, that's not really factoring there. So here I need the same denominator. So this one needs an x plus 3. There's a 3 there. This one needs an x plus 5. So I would have the same denominators. So this becomes one big fraction. The denominator is x plus 5 times x plus 3. And this is just, x plus 5 plus 2x plus 6. And then you're just going to simplify that. It looks like that would be 3x plus 11 over x plus 5 times x plus 3. Okay, just factor everything. This is one of those fun problems you get to cancel, hopefully. That's the goal. So this will be, let's see, that first one would be x and x. Factors to 6, so it's got to be 6 and 1, I think. Adds up, wait, will it add up? No, it's not 6 and 1. Ooh, that's bad. Okay, how about 3 and 2? 3 and 2. Okay, one of them's negative, so the bigger one has to be negative. I think that works. Okay, good. The denominator of the first fraction would be x times x plus 2. So you see that GCF there. In the second fraction, you got x squared times x plus 1, and you have x, so you've got to be 3 and 1, and minus, and plus, the bigger number is negative. So I see x minus 3 cancels. One of the x's cancels, so I'm going to take out that exponent. It was 2 x's up there, now it's just 1. X plus 2 cancels. This is awesome. X plus 1 cancels. I think we just have an x, so I think all that simplifies to just x. Pretty fun. Okay, this one, the first thing you want to do is flip that, right? So this second fraction is going to be flipped there. So the first fraction will just be x minus 4 over x plus 2, x minus 2, times, I'm going to put this bottom one up top, so if I simplify that or factor that, I guess that'll be x plus 2, x plus 3. Put the top one down to the bottom, so that'll be x, looks like 4 and 1, I'm guessing. The bigger number is negative, so minus 4 plus 1, I think that works. Put parentheses around that. So x minus 4 goes away, x plus 2 goes away, and I think we have x plus 3 over x minus 2 and x plus 1. Okay, so this one, think about the end in mind. So think about what we'd like that denominator to be. We'd like it to be cube root of x to the third. It's only cube root of x to the first, so we need to multiply by cube root of x squared to get that to happen. Squared, cube root of, that's a third root of x squared. And so that simplifies to be 2, that's 2 there, 2 times cube root of x squared on top and x on the bottom. I don't want you to skip those two, so let's see if I can write on them. Can I write on this? No, I can't. So 1 over, let's see, 1 over the square root of x plus 3, okay? 1 over square root of x plus 3. So that's going to be a conjugate situation. So you're going to multiply by the conjugate, square root of x minus 3 is the conjugate of square root of x plus 3. So I change the sign in between. I don't change the two numbers. So pretend that's a fraction bar there. So up top you would get square root of x minus 3. And down below, the first times first would be x minus 9, I believe. So it's a big fraction there. That would be your answer. And number, let's see, 24, 1 over 2 over square root of x minus 1 plus square root of 5. 2 over square root of x minus 1. Okay, so plus square root of 5. Okay, so this is going to be, we're going to multiply by the conjugate here. So not equals, we're going to multiply by the conjugate because we've got a binomial with square root. So square root of x minus 1. I'm not changing the sign inside of there, changing the sign in between the two terms. So really neither of the two terms actually change. That's all under the radical minus square root of 5. Okay, so in the denominator, you're going to have x minus 1 minus 5. Or in other words, the denominator is going to be x minus 6. Numerator is just going to be 2 times square root of x minus 1 minus square root of 5. That would be fine to leave it like that. Find the domain. So really, I'm just looking at that denominator. If you can factor that, that'll make a big difference here. So x and x, I think 8 and 1, minus and plus. So all reals, but x cannot be 8 or negative 1. Here you take whatever's, because it's a square root, whatever's in the underneath the radican there, because it's an even root. You say, well, that has to be non-negative. So 3x plus 1 greater than or equal to 0. Just subtract 1 to get 3x greater than or equal to negative 1. Divide by 3x greater than or equal to negative 1/3. That's actually your domain. You don't have to change it at all. Cube root, you don't have to do that because you can take cube root of odd numbers, negative numbers, positive numbers, 0. So this is going to be all reals for all cube roots, pretty much. That's your review.